Hello, so today my student and I, we went over numerous things. We went over the area of a rectangle. We went over dividing decimals, and we went over the differences between physical and chemical changes. So for area, we know it's length times width, and we were given that the area of the rectangular roof was 756 inches square, and that the length was 108 inches. And we were told to find W. And to do this, we can isolate for W by dividing each side by 108 inches. And we do this because we want to isolate W. And to do that, we can divide by 108 to create 1 times W, because 108 over 108 is 1. And that isolates W. But if we do that to the right side, we have to do that to the left side. So in algebra, whatever you do, you have to do it on both sides. And then we found out the width was 7 inches. And then for dividing with decimals, it's like dividing with any number in long division. You just have a decimal point in there. And the specific problem was that if you were going at 45.14 kilometers an hour, and 5 hours ago you were going 4 times slower. How fast were you going 5 hours ago? And we do that by dividing this by 4, since we were going 4 times slower 5 hours ago. And like I said, you do it like any other problem, any other long division problem. Wait, actually, I'm going to draw this a bit bigger so I can show all my work. Okay. Okay, so right here we encounter a problem. So we have a remainder of 2 at the end, but we aren't, because we don't have any other spaces to fill, right? We already used up all 4 of our spaces, but we already have, we still have a remainder of 2. We don't want any remainder in long division. And to fix this problem, and by adding more spaces, we can add a 0 here. And that works because no matter how many zeros you add to the right of a decimal place, it's still that number. So if it's like 1.0000000, it's all still 1, because it doesn't matter if you add a zillion zeros to the right of a decimal place, it doesn't matter. So we drag the 0 down there, and uh, 4 goes into 25 times. So our answer would be 11.285 kilometers an hour. And that's how fast we were going 5 hours ago, because that is uh, a fourth of the speed at our current rate. And then we went over physical versus chemical changes. So basically, she had a hard time understanding that water doesn't chemically change from a solid, liquid, or gas. And this is because it's still H2O molecules in a solid. They're just more tightly bound together, and they're slowly vibrating. And then in a liquid, it's still the same H2O molecules. They're just going around at a faster pace. They're allowed to move around even more. And then for gas, it's still H2O molecules. It's just the particles are even going faster, and they're allowed to move wherever they want. It's not chemically changed. A chemical change would be like if you burn something, if you burn like paper, because you're chemically changing the formula of paper. Because once you burn paper, it doesn't have the same chemical structure that paper once had. You can't revert it back to paper. While if you were to cut paper in half, that's a physical change, because it's still paper. It's just cut in half. You can fix it by putting tape on it, or yeah, it's still paper. So physical change, it doesn't change the chemical property of it. You can do whatever you want to it as long as you don't chemically change it. Chemical changes if you're actually changing the chemical formula for it. So if it's like you're making water or something from hydrogen, oxygen, that's a chemical change. But H2O phase changes, those are uh, those are physical changes because solid, liquid, and gas, it's still your same H2O molecules. It's just um, arranged differently. So thank you.